All right, so we have to come up with a rule for how to take the derivative d dx of f of x times g of x, because there are times we simply don't want to multiply them together. And we call it the product rule because it's f of x times g of x, that's the product. Now, how do we do derivatives? They're always the same. Well, first of all, let's call this like yesterday, like we had in the past. Let's call capital F g of x times f of x. And we know that if we want the derivative, we have to do the limit. All right? Now, this gets a little funky. All right? It's not that hard to do, but we're going to have to go through and do all of this. It's going to take some separation, and there's one kind of giant leap step that students typically don't see. So let's start taking the derivative. I will plug in x plus h into my functions, all right, and start doing the derivative here. Limit as h goes to 0 of f of x plus h times g of x plus h, right, minus f of x times g of x all over h. Now, we look at this and we know that what we're going to want to do is somehow separate the f of x and g of x, right? So we can find derivatives and make it something we can see. But I'll level with you. Right now, this is just a disaster. There's nothing here to separate. So we're going to have to do something creative. And often, unless the teacher would have shown me the first time, I would have never seen it either. So I'm going to do what has to be done. Take the limit as h goes to 0. Of h, all right? And I'm going to add two terms in the middle. I'm not going to change the first term or the last term. That's the same. Now do it in a different color. What I am going to do to help be able to do this is I'm going to put this in. Now if I put a negative f of x plus h times g of x in there, I'm going to have to do what? Put a positive, because they cancel. Do we agree this is a legal thing to do? We can always add 0, and that's what we just did. But this helps us a ton, all right? Because what I can do here now, if you look here on the first two terms, you see that f of x plus h is common in the first two. So I'm going to make a limit here now, and I'm going to pull that limit out. I'm going to pull out f of x plus h, and that's going to leave, you guys agree it's going to leave g of x plus h minus g of x all over h on the first two terms. What can I pull out in the next two terms that's the same? When you look at the next two over here, what can I, g of x can come out of those two. So I will go, and it's a plus sign, you guys agree? So I'll go plus g of x, and what's that leave on top? That leaves f of x plus h minus f of x all over. Listen, when you look now at these two things, you should know what they are. What is, if I look at the left one here, what is this here? That's the derivative of g. Everybody look at this. Limit as h goes to 0 is over here on the left. G x plus h by, this is the derivative of g. So let's bring the limit in and just simplify this, because the limit can jump in. So I got f of x plus, I got the limit as h approaches 0 of f of x plus h, all right, times, and I suppose I can write this all out as we see it the first time. We know our limit laws allow us to do this. That's the first term, right? And it's so long, I'm going to need to make it a little smaller. So the f there. Good enough. And the next term is plus the limit as h goes to 0 of g of x times the limit as h goes to 0 of f of x plus h minus f of x all over h. And again, it's just what we said. Think about it. If this limit goes to 0 here, is there any reason I can't just put 0 into h? No, because it doesn't go to, it doesn't have a bottom 0, and we know it's polynomial. So this first term becomes f of x. What's this become? Well, just like we just said here in class, this becomes g prime, right? What's the next thing? Well, I plug in h goes to 0, this just becomes g of x, and what's the other thing? F prime of x. And guess what we just found? We just found the derivative. And a lot of times I simplify, guys. I'm not interested in writing out all the x's usually. So this becomes f of x, g prime of x, plus g of x, f prime of x. And this is the product rule. It is something we have to know. And often I cheat. All right, when I write this, if I'm going to simplify this, I write this. d dx of fg, I drop all the x's. fg prime plus gf prime. All right, that is called the product rule. The function of f times the derivative of g plus the function of g times the derivative of f. So let's try one. Here. So let's take a look at an example. Now this is one where you should be able to figure out the derivative the old-fashioned way. So we all agree that you can simplify f of x over here to 42x7 and get 7 times 42 is 280 plus 14, 294. x6 is the answer. Do we all agree? Before we even start, we know we've got that answer. So let's do the product rule. Okay? Let's do the product rule and see if we can't get that. Again, this is a good case to start with. Everybody, I'm going to call this f of x. I'm going to call this g of x. And the derivative rule of fg is f prime g plus g f prime. Okay? Sorry. No, I'm sorry. The book does it the other way. I learned it backwards. There, fine. It doesn't matter. It's all right. Now, so as I do the derivative of f of x, f prime of x, doing the product rule. Does everybody agree when we look, f of x here was 6x cubed? What's the derivative of just the g part? 28x3, I agree. Plus, g of x is 7x4. What's the derivative of just the f? All right. Now we do a little bit of math, all right, which is always fun. So I get 168x cubed plus 7 times 18, 70 plus 56, 126. I said x cubed and I wrote x3. I meant x6. And what do you think 168 plus 126 had better be? It is 294x6 because they are like terms. Boom. And again, this is a nice example, but it's not really one where we want to apply the power rule typically. Okay? We are more interested in those product rules for other examples here. So here, let me put one on the board. I'll pause again so I can load it up. Now, here's a better case of the product rule, okay? And I'm going to work through the book example. It says h of x equals x times g of x. All right? And it's known that g of 3 is 5 and g prime of 3 is 2. And I want you to find h prime of 3. All right? This is definitely a case where you need the product rule. All right? Because we can define this. Now, a lot of times students get confused when we think of x times g of x. Well, this is the product rule, okay? So if I work down the board, the first thing I hope they do, first thing they do is they find h prime. d dx, all right, of x, g of x. Well, the first function is x, the second function is g of x. So x times the derivative of g of x plus g of x times the derivative of x. What's the derivative of x, everybody? All right. So they simplify this. And looky. X stays the same. Derivative of g of x is g prime plus g of x times 1 is just g of x. So they want you to find h prime of 3. So they want you to insert 3 here, here, and here. Well, think about this. They gave us these two things for a reason, didn't they? And now, plug them in. Plug and shove. As fast as we can go. 3 times g prime of 3 plus g of 3. 3 times Up here it's 2, right there, plus right here geometry is 5. 6 plus 5 is 11. So the rate of change of h of x when x is 3 is 11. Guys, can you picture that? That's an awfully steep line. That's like, boom, it's getting there, all right? All right, so that is, and this is a very good case for the product rule. Now we tie this together later with the quotient rule and the chain rule. We have some real power. So we got some rules to work. So yes, these are memorization, all right? It could have been used for the last problem on the test. Yep. So that is the definition of the product rule and a couple examples.